The unsung hero of electronics, understanding resistors. Introduction. In the world of modern electronics, resistors are often overlooked. They do not light up like LEDs, store energy like capacitors, or amplify signals like transistors. Yet, without resistors, none of these components could function properly. Resistors are the quiet guardians of circuits, controlling, limiting, and balancing the flow of current to ensure everything works as designed. What is a resistor? A resistor is a passive electronic component designed to oppose the flow of electric current. It introduces a specific amount of resistance, measured in ohms, ohm symbol, to control how much current flows through a circuit. Think of it as a traffic officer, regulating the movement of electrons to prevent overload or damage. Functions of a resistor. Resistors serve several crucial functions in modern electronics. Current limiting with resistors. Current limiting is one of the most important roles of a resistor. In electronics, every component has a safe level of current it can handle. Too much current flowing through a device, like an LED, microchip, or sensor, can burn out instantly. That's where a resistor steps in. A resistor acts like a flow restrictor in a water pipe. Just as a valve keeps water pressure from bursting your pipes, a resistor reduces and controls the flow of electrical current so that components only receive what they can safely handle. Example in real life. When you connect an LED directly to a battery, it will likely burn out because the current is too high. By placing a resistor in series with the LED, the resistor absorbs part of that current, keeping the LED safe and glowing at the right brightness. Why it matters. Prevents overheating and damage. Increases the lifespan of delicate electronic parts. Ensures consistent performance of devices. Voltage division with resistors. Voltage division is another clever role resistors play in circuits. Imagine you have a big slice of electricity, a higher voltage, but one part of your circuit only needs a smaller slice. How do you split it up without frying anything? That's where resistors come in. When resistors are arranged in series, they naturally share or divide the voltage between them. The ratio of this sharing depends on their resistance values. In other words, resistors act like measuring cups, taking a large jug of voltage and pouring out just the right amount where it's needed. Real-life example. A microcontroller might only need 3.3 volts, but your battery provides 9 volts. By arranging two resistors in a voltage divider, you can tap off the smaller 3.3V portion while the rest is used elsewhere. Why it matters. Provide safe operating voltages for sensitive components. Use in sensors like temperature or light sensors to convert changes into readable voltage signals. Essential for analog to digital conversion, where signals must be scaled down to fit a device's input range. Heat dissipation with resistors. Whenever electricity flows through a resistor, part of that electrical energy is converted into heat. This isn't a flaw. It's actually one of the ways resistors keep circuits stable and safe. Think of a resistor like a pressure release system. If too much electrical energy is present, the resistor absorbs and burns off the excess in the form of heat. This keeps other delicate components from overheating or breaking. Everyday examples. In a phone charger, resistors help regulate power, so your device charges safely without spikes. In audio equipment, they stabilize signals by bleeding off extra energy that could distort sound. In high-power circuits, special wire wound or ceramic resistors are designed specifically to handle and dissipate large amounts of heat. Why it matters. Prevents dangerous overheating. Protects sensitive chips, LEDs, and sensors. Maintains reliability by keeping circuits balanced under load. Backhand index pointing right in short. Resistors act like electrical shock absorbers, converting what could be harmful energy into harmless heat, ensuring smooth and safe operation. Signal conditioning with resistors. In electronics, not every signal that flows through a circuit is ready to use. Sometimes signals are too strong, too noisy, or not in the right shape for the next stage of the circuit. Signal conditioning is the process of cleaning up and preparing those signals, and resistors play a quiet but powerful role here. Resistors, often paired with capacitors or inductors, act like filters and shapers. Filtering noise. Resistors help remove unwanted electrical static so that only the useful part of a signal gets through, like turning down background chatter, so you can hear the main speaker. Shaping signals. They can smooth out sharp edges, adjust timing, or reduce spikes, making the signal easier to process. Level adjusting. Resistors can reduce a strong signal down to a safer level, preventing distortion or damage to sensitive circuits. Everyday examples. In radios, resistors help filter out static, so you can tune clearly to one station. In audio equipment, they prevent loud pops or crackles by smoothing signals. In sensors like temperature or motion detectors, resistors condition weak signals, so microcontrollers can read them correctly. Why it matters. Ensures clear communication in devices. Protects electronics from bad signals or surges. Makes sensors, radios, and digital systems reliable and accurate. Backhand index pointing right. In short, resistors and signal conditioning are like editors for electricity, cutting out noise, balancing the flow, and making sure the message gets through clean and clear. Biasing active devices with resistors. Active devices like transistors, diodes, and amplifiers don't just work when you hook them up. They need to be set at the right starting point to function properly. This setup is called biasing, and resistors are the go-to tool for making it happen. Think of biasing like tuning a musical instrument. If a guitar string is too tight or too loose, the sound will be off. Similarly, if a transistor isn't biased correctly, it won't amplify signals properly, or worse, it might not work at all. Resistors and biasing circuits control the flow of current and voltage at the input, so that the device stays in its optimal sweet spot of operation. Everyday examples. In an audio amplifier, resistors bias transistors, so the sound comes out clear instead of distorted. In radio circuits, resistors bias transistors to make sure weak signals can be boosted without being drowned in noise. In digital electronics, bias resistors ensure logic gates read signals correctly. A 1 stays a 1, and a 0 stays a 0. Why it matters. Keeps transistors stable and efficient. Prevents distortion in amplifiers. Ensures reliable operation of diodes, sensors, and ICs. Backhand index pointing right. In short, resistors and biasing act like steady hands on a dial, keeping active devices balanced so they can perform their job consistently and accurately. Protection. Resistors as circuit guardians. One of the most overlooked but vital jobs of a resistor is protection. Electronics are sensitive. A sudden surge of current, a voltage spike, or even static electricity can damage components instantly. Resistors act as tiny guardians, stepping in to absorb or limit harmful energy before it reaches delicate parts. How resistors protect. Current surge control. They limit sudden inrush currents when a device is powered on, like preventing a light bulb from popping when first switched on. Voltage damping. Working with capacitors, resistors absorb sharp voltage spikes, called transients, that can come from power lines or switching devices. Static discharge safety. In circuits handling static-sensitive chips, resistors safely bleed off unwanted charge buildup instead of letting it fry components. Fusible resistors. These special types act both as a resistor and a fuse. They carry normal current, but if there's a dangerous overload, they burn out gracefully to save the rest of the circuit. Everyday examples. In phone chargers, resistors protect against sudden surges when you plug in. In cars, resistors help protect sensitive sensors and electronics from spikes when starting the engine. In computers, resistors prevent damaging currents from zapping microprocessors. Why it matters. Extends the lifespan of devices. Prevents costly damage from unpredictable spikes. Keeps electronics safe, stable, and reliable in real-world conditions. Backhand index pointing right. In short, resistors act like shock absorbers and safety valves in electronics, quietly guarding against dangers you never even see, so your devices run smoothly and safely. Conclusion. Resistors are the unsung heroes of electronics, small in size but massive in impact. They regulate, protect, and balance every circuit, ensuring that technology works seamlessly in our daily lives. Whether you're charging your phone, adjusting the volume on your stereo, or relying on medical equipment, resistors are working quietly in the background to make it all possible.